Welcome pre-calculus students, Mrs. Fellon here. We are on Unit 1, Lesson 3. So the title of this unit is Unit Circles and Not So Unit Circles. And so what we're trying to get at here is this idea of how to basically solve an angle that's on the unit circle, but also look at some angles that are out of the unit circle, not on the unit circle. And so the reason why that's important is because in our study of trig, in which we'll eventually get to here, you're going to be looking at all different kinds of angles. And the ones that are on the unit circle are very special, right? They're the ones that are make up of those special right triangles when the hypotenuse is 1. And they, a lot of times, they have that reference angle of 30, 60, or 45, or they're one of those quadrantals. What we're doing here is we're kind of doing the opposite of what we did in Lesson 2. So just as a recap, in Lesson 2, what we did is we were asked to evaluate. So to evaluate, what that means is you're looking for the x or y or in tangent's case, y over x ratio of an angle. So like, for example, cosine of pi. What you're given here is pi is your angle. You're asked to take the cosine of it. Well, cosine is a ratio of your x distance, remember, over your hypotenuse, x distance over this diagonal distance. And so when I ask you to find cosine of pi, I'm asking you to find, and if it's on the unit circle, I'm asking you to find the x value, okay? If I ask you to find sine, we're looking at the opposite over adjacent, or in other words, y over 1. And so we're asking you to find the y distance. So when you evaluate, you're giving me a ratio. Since it's just a number like x, whatever that x value is or whatever that y value is. In tangent is where it shows up more often as a regular fraction of whatever your y value is over whatever your x value is. And so again, when you are evaluating, you're asked to find a ratio of your side lengths. What we're doing here is we're actually solving equations. Notice how these ones are a little bit different. You'll have like sine of theta equals 1/2. So when you were evaluating, you were given the angle. It had been like sine of 150 degrees or sine of 2 pi over 3, meaning that 2 pi over 3 or 150 degrees was your angle measure. And then in this one, we're giving you the ratio of your side lengths. So we're telling you that the ratio, which is y over 1, because we're going to be talking about on the unit circle for these ones. So it's y over 1. So that ratio is equal to 1/2 is what I'm giving you. What we're asking you to find here is what angle produces that. So there's a couple things. I like to write down a couple different kind of guidelines. I don't think you learned this in Algebra 2, so this may be brand new. If not, this is a review and you can just kind of review this with us as a whole group. So it says determine the angle or angles that make each equation true from 0 to 2 pi on the unit circle. So what they're getting at there is, let me kind of go back to this idea. We're going to do something basic, sine of 30 degrees. So again, this is back to evaluating. So sine of 30 degrees, so if I draw my 30-degree angle and I label my sides, right? And I said sine of 30 degrees would be my y value over the radius, which is 1. So I guess I didn't need the equals twice, but I would get sine of 30 degrees is equal to 1/2. Well, look what happens when I do sine of 150. So you probably have done sine of 150. So 150 would be in quadrant 2. So that's this angle here. We drop this down to make our right angle. Our reference angle is 30, because if this is 150, we know that all the way around, halfway around, I should say, is 180. So we'd label our side lengths, keeping in mind that that x distance is negative. But we're asked to find sine, which is y over 1, which in this case is 1/2. So if I'm asking you to find, if I'm asking you to do sine of an angle equals 1/2, there are actually two answers to this question. There's that 30-degree angle, and there's a 150-degree angle. And so this is why in the directions it says determine the angle or angles, that's why that's in parentheses, that makes this equation true. Because in most cases, there's more than one, there's generally two angles that make that equation true. So if you might be thinking, well, wouldn't that be true for all 4 quadrants? If we put a 30-degree So remember, if we put 30 degrees in the quadrant 3, this would be a half, right? And this would be root 3 over 2 because that's your 60-degree angle. But remember that our side lengths here, our x and our y value are both negative. So if I asked you for, let's see, this would be sine of 210, right? 180 plus 30 is 210. If I asked you for sine of 210, it would be y over 1, which would be negative a half. And so in this case, obviously negative a half is not equal to a half, and that's why this one is different. That's why there's only 2 answers to this equation here and not 4. Because if I put my reference angle in quadrants 3 and 4, my y values are negative down there, and therefore not equaling a half. So that's ultimately what we're going to do, is we're gonna basically solve our equations for theta. We're asking ourselves, what angle gives me this ratio? So if I'm using this sine or this trig function on an angle and I get 1/2, what must those angle or angles be? So I like to kind of, like I said, write down some steps. So the first thing I do is I determine which quadrants the trig function is positive or negative in. I'm gonna write that down. So the function So I'm going to go back to my example with sine, and I know that's the same one here. But if I looked at my first example and I want to know where sine is equal to a half, I want to know when y over 1 is equal to a half. So down here, the first thing I'm going to say is, well, I'm going to get rid of these 2 quadrants. And the reason why is because in order for y to equal a half, it cannot be in quadrants 3 and 4. And the reason why is because y is negative in quadrants 3 and y is negative in quadrant 4. So this is what I mean by determine which quadrants the trig function is positive and negative in. So out of the 4, I eliminated 2 of my quadrants just because I'm looking for positive 1/2 and not negative 1/2. If I was looking for sine of theta equals negative a half, then I would be looking for answers in quadrants 3 and 4. All right, so step 2 would be to draw your right triangle to the x-axis and label your reference angle. So some of this seems, I always do these steps, but as you get more comfortable with this, you probably will be able to skip some of this stuff. Okay, so draw the right triangle to the x-axis and label your reference angle. So the ones we're talking about here are going to be on the unit circle. So again, your reference angle is like 30 degrees, 60 degrees, 45 degrees, that kind of thing. So for example, on our example here with sine, I would draw in an angle in the first quadrant, and I would draw in my right triangle, and I would do the exact same thing in quadrant 2. So there's my right triangle. Put the little thing in here. So how do I know what reference angle it is? Well, use the information provided. You already know that your y distance is a half because that's what was provided in the problem. So if y is a half, what must this angle across from a half be? And that's our reference angle of 30 degrees. So that's back, I think, in lesson 1 when we were, maybe it was lesson 2, when we were getting at this idea of like if I had a 30-degree angle, the side across from it's 1/2. So we've been kind of doing that. Okay, I have a 30-degree angle, now I can label my sides. Well, now we're working backwards. If you're given the side, and you now know that the angle across from it is that 30 degrees. And so that's ultimately what we're doing here, is we're just kind of filling in the information that we're provided. Okay, so now we have that. Next step, or last step, I should say, is to name the angle in both quadrants. So we're going to name our theta, or our angle, in both quadrants. So this is where those 2 answers come into play. I'm going to put in parentheses here, radians or degrees. Sometimes we will ask you for answers in radians, because remember, we're solving for an angle right now. So sometimes I'll ask you for the angle in radians, sometimes I'll ask you for it in degrees. How do you tell? Pay attention to what I'm asking you for at the beginning. So it says, determine the angles that make the equation true from 0 to 2 pi. 0 to 2 pi is in radians, right? This is radians. So therefore, I want my answers in radians. If this said, give me the angles that make the equation true from 0 to 360 degrees, then your answers would be in degrees. The other reason why we give you these parameters is because technically there's infinite, if I didn't, there would be infinite number of answers for this particular equation. Because remember, not only is in this case, 30 degrees is going to equal sine of 30 degrees is going to equal 1/2, but every coterminal angle to 30 degrees. So think 390 degrees, you know, and then add 360, add 360, add 360. So technically, if we did not put some parameters and just ask you for numbers between 0 and 2 pi or between 0 degrees and 360 degrees, your answers would be infinite. So, all right, so where it says name the angle in both quadrants. Well, this is quadrant 1, so my angle is 30 degrees. So we're going to name the angle in the second quadrant. We can't call it 30 degrees because that's not a second quadrant angle. So we have to think about what angle this is that made that reference angle of 30 degrees. And so if you remember from my example, we know that if this is 30, then this whole angle has to be 150. And since I just gave you answers in degrees, let's go ahead and change those back into radians. All right, so degrees to radians, if you remember, 30 degrees is pi over 6. So remember, it was kind of the opposite. 30 is pi over 6, and 60 is pi over 3. The easiest way for me to change 150 degrees, now I know that you can do the conversion. I really, really, really want you to get into the habit of, you know, not always just using the conversion factor to be able to change from degrees to radians. I want you to actually start thinking in radians. It would be a lot easier, and especially if you plan on going to calculus and so forth, the easier, the more you kind of can think in radians or reason with radians and not have to do like that whole conversion of multiply by pi over 180 all the time, the quicker you will be. So what I'm getting at here is we already know in radian form, right? This is pi, okay? All we're doing is we're talking about this is 30 degrees less than pi. All right, so we already know that it's pi over 6 is my reference angle, right? So let's make this, instead of calling it pi, I'm gonna call it 6 pi over 6. Why? Because I want it to have the same denominator. Remember, we're talking about fractions here. So I can call this 6 pi over 6 or 5 pi over 5 or 432 pi over 432. It all equals the same thing. It's all 1. And so now if I take 6 pi over 6 and I subtract 30 degrees, just like if I took 180 and subtracted 30 degrees, I get 150. If I take 6 pi over 6 and subtract pi over 6, I would get 5 pi over 6. And so maybe you're thinking, oh my gosh, that's a lot harder, or that's a lot longer than just multiplying by pi over 180. And to be honest with you, the more you do it, honestly, it's not. And so I want you to start thinking in terms of pi. So any angle in this quadrant here, think about what you did to get to that angle. You either took 180 and subtracted your reference angle, or you took pi, or in this case, 6 pi over 6, and subtracted your reference angle. And so that's just going to be always true for every angle that's in quadrant 2. Okay, so this is about what cosine is. It says determine which quadrants the trig function is positive or negative in. Cosine is the ratio of x over 1. So where is x negative? X is negative in quadrant 2 and quadrant 3. Okay, so that's how I can kind of eliminate these two quadrants, 1 and 4. Next, I'm going to draw my right triangle. And you can draw it in both quadrants or one. It doesn't really matter. Whoops. Oh well. I'll draw it in both. And then we're going to label our reference angle. Well, okay. So again, provided the information, what information am I provided? I'm giving you your x value. So that's this length right here. It's negative root 3 over 2. What must my reference angle be if this side length right here is negative root 3 over 2? So you might think, oh, well, think about what we already know about evaluating. Negative root 3 over 2 is across from 60 degrees. And if this is 60 degrees, then this has to be 30 degrees. So our reference angle that we're talking about here is 30 degrees. I'm going to call it pi over 6 since, again, we're talking about radians. Last question, or last part, is just name the angle in both quadrants. So again, now we're in quadrants 2 and 3, so we need to name an angle between 90 and 180, or between pi over 2 and pi. And then we need to name an angle between 180 and 270, or pi and 3 pi over 2. So we're talking radians, so we're going to deal with radians. So this is the same thing as we did in the last one, right? They had our same reference angle of 30 degrees. I can make this 6 pi over 6, since that's 1 pi right here. I'm going to subtract 30 degrees, or I'm going to subtract pi over 6. I get 5 pi over 6. Well, think about how you get to angles in quadrant 3. If you know that this is 180 and then we're going to add on 30 degrees. So if this is 6 pi over 6, I'm going to add on pi over 6. That gives me 7 pi over 6, or 1 1/6 pies. So those are my two angles that satisfy this equation. Then we can make it even more fun. We can start giving you some more parameters. Tangent always kind of throws a loop for people. You got to remember what tangent represents and think about tangent being a ratio between y and x. So let's start there. So I'm going to take this part of this problem here. I gave you a second piece here. We'll deal with that in a minute. So tangent is and that's just a different Greek letter, but tangent of your angle equals -1. So where is tangent negative? All right, so you have to remember that tangent is y over x. It's the ratio of your y side or opposite side over your x side or your adjacent side. So in this one, the only spot where y over x, in this quadrant, y's are positive, x's are positive. So a positive divided by a positive would give me a positive. So it's definitely not negative here. In this quadrant, it would be a negative y and a negative x value. Negative divided by a negative also is a positive. So the two quadrants we're actually referring to here are going to be quadrant 2 and quadrant 4. This second piece of information just kind of narrows your choices down even more. So I'm asking you for secant of your angle is less than 0. So remember, secant is the reciprocal of cosine. Wherever cosine's positive, secant's positive. Wherever cosine's negative, secant's negative. So I'm looking for when secant is less than 0, or in other words, secant is negative. So you can also just think, where is cosine negative? Well, cosine is negative. Cosine is x. It's negative over here in quadrant 2. So I'm going to go ahead and eliminate quadrant 4 as my next choice. So now I only have really one particular answer for this one, because I'm only down with one quadrant left. All right, so now here's the fun part, because this is tangent, right? So it's not like it's just x or just y, it's a ratio. So what must our reference angle be if y divided by x equaled -1? So let's think about that. In order to get 1, or -1, you have to divide something by itself, right? It's like 4 divided by 4, 8 divided by 8, -2 divided by -2. So in order to get -1, one of these values is positive, one of them is negative, which is what we got going on here in quadrant 2. The x is negative, the y is positive. So we got that. And what we know is that those two have to be the same. In order for us to get this to equal 1, they have to be the same. Well, which of your special right triangles has both side lengths or both legs the same? Hopefully you're thinking, oh, 45 degrees, right? That's that reference angle, because it's the only right or special right triangle that has both legs to be the same measurement. All right, let's label our side length. So if we know that tangent is -1, whoops, I need to make that positive. We know this has to be √2/2 and this has to be √2/2. That's how we got the -1. We did positive √2/2 divided by negative √2/2. All right, so let's name this angle. Kind of looks like a fish. It's okay. So it's a 45-degree angle in quadrant 2. So 45 degrees, this is our angle here. 45 degrees is pi over 4. So I'm going to call this 4 pi over 4. It's, again, just another name of saying 1. So 4 pi over 4 minus pi over 4 would be 3 pi over 4. All right, let's keep going. Sine of this other now different Greek letter. So sine of your angle equals √2/2. Again, sine is y over 1. So when is y positive? Y is positive in quadrants 1 and 2. So if I know my y value is √2/2, what must my reference angle be? Again, what you're trying to find here is your angle measures. So that's what we're trying to get at. It's 45 degrees. The other piece of the puzzle says tangent of that angle has to be greater than 0. In other words, tangent of that angle has to be positive. So I can eliminate here because I know that in this quadrant, my x's are negative, my y's are positive, which makes tangent negative. So I'm going to be down to one answer in this case. So my angle would be a 45-degree angle in the first quadrant, or in other words, pi over 4. Let's do some reciprocal functions. Those tend to be a little bit trickier. What I normally have you guys do with reciprocal functions, that's like your cotangent, your secant, your cosecant, is I have you really just change them right from the beginning. So the reciprocal of cotangent is tangent. And then I'm going to have you flip this. So negative root 3 over 1. So these two things are equivalent. This is cotangent of negative 1 over root 3, and this is equal to tangent of that same angle equals negative root 3 over 1. I just think it's easier to deal with the original function and not the reciprocal function. So that's what I do first. So then I go through the same process. Where is tangent going to be negative? So we talked about that in one of the previous problems, right? We know tangent is positive in these two diagonals, so in quadrants 1 and 3, and negative over here. So I'm going to draw my right triangle. So we know this is not a 45-degree angle. And how we know that is because in order for this to be a 45-degree angle, it would have to either be tangent of negative 1 or tangent equals positive 1. Because that's the only way that y over x is going to equal that. So this is either 30 or 60. And so to be honest with you, it's easier if you memorize this. So there's only two choices. It's either 30 or 60. And you're basically saying, is this root 3 over 2 divided by 1/2 or 1/2 divided by root 3 over 2? So which one gives me negative root 3 over 1? So let's try 60 degrees. So if you're unsure, you can always try. So if this were 60 degrees, this side length would have to be root 3 over 2. This side length would have to be 1/2, right? And so the same thing on this side as well. Whoops, this is negative, don't forget. All right, so if this were indeed 60 degrees, let's just check. Tangent would be opposite over adjacent, or y over x. So root 3 over 2 divided by negative 1/2. Does this give me negative root 3? If it does, then I know I picked the right angle. If I didn't, then I know I switch them. So let's do the math. So I have root 3 over 2 times negative 2 over 1. Yeah, it gives me negative root 3. So I know here that this is a 60-degree angle. So again, if I tried this and then, y over x gave me something other than negative root 3, then I know that this would have to be a 30-degree angle because it can't be 45 and there's only 3 choices. Okay, let's name our answers. So we want a 60-degree angle in quadrant 2 and a 60-degree angle in quadrant 4. So 60 degrees is pi over 3. So I'm going to call that 3 pi over 3. So to get this angle, I would just subtract pi over 3. So 3 pi over 3 minus pi over 3 is 2 pi over 3. So if this is 1 pi, this is 2 pi, right? Well, 2 pi with a denominator of 3 looks like 6 pi over 3, right? Isn't 6 pi divided by 3 just 2 pi? It's just another way of naming that angle with a denominator of 3. So I'm going to call this 6 pi over 3 over here. So to get to your angle in the 4th quadrant, so think about how you would name this angle. Let me use a different color. So we're talking about this angle here. Okay. So we're talking about this angle here. How you would normally find it is you would take 360 degrees and subtract 60. So in other words, that would be 300. But since we're in radians, we take 6 pi over 3 and subtract pi over 3. So 6 pi over 3 subtract pi over 3 is 5 pi over 3. One more for fun. It's another reciprocal function. I would encourage you to go ahead and switch this around. So the reciprocal of secant is cosine. And the reciprocal of root 2 is 1 over root 2. You're not going to see something that looks familiar here because of the whole radical on the bottom. So let's rationalize that. And that's a multiplying. And so I have root 2 over 2. So so now what I'm really saying here is I'm saying cosine of theta is equal to root 2 over 2. That should seem familiar. So let's go ahead and think about when is x over 1, or cosine, going to give me a positive root 2 over 2. So x is positive in quadrants 1 and 4. I'm going to draw in my right triangle. I'm going to label my x side as root 2 over 2. You probably guess anytime that you're dealing with root 2 over 2, my reference angle is 45. And again, that's all we're really trying to find here. Since we're talking about radians, I'm going to go ahead and call that pi over 4. So in quadrant 1, we just name it pi over 4, right? To get to my fourth quadrant angle, I would take 2 pi and subtract pi over 4. So to make it a denominator 4, 2 pi is 8 pi over 4. Subtract pi over 4, and I get 7 pi over 4. All right, let's look at some that are not on the unit circle. So this is a little bit longer video, I apologize, but just lots of fun things to look at. Okay, so now we're gonna look at not on the unit circle. So pick a radius, it doesn't really matter what it is. So I'm just gonna pick 10, just for fun. Will the x value still be equal to the cosine of that angle? So let's think about this, okay? So I have let's say I have a unit circle. So I'm going to draw a circle here. And this one's a unit circle, which means this is 1, this is 1. And I'm looking at my, so if I know that this whole radius is 1, I'll erase that. I know the radius is 1, okay? So what I'm trying to get at is if I change the radius to be something else, will it change my x value? So here, I know that if this were, let's say, 30 degrees, okay, then I know this side length would be 1/2, that's my y value, and my x value would be root 3 over 2. So I would say cosine of 30 degrees is root 3 over 2, okay? What happens if I change that radius? So now let's talk about it when it's not on the unit circle. Okay, so now I want this radius to be 10. That's the number I picked. So if I draw my right triangle down, right, and I ask us to find what this x value is it going to equal root 3 over 2? Is it going to equal the same thing as the one that was on the unit circle? So you can do this a couple ways. Probably the easiest way is to think about it more geometrically. If you have a radius of 1 and now you're changing it to a radius of 10, you're scaling it up by 10. Okay, which means you're also scaling up your side lengths by 10. So that means you're going to take your x value, which is root 3 over 2, and times it by 10, because you're scaling it up. So I would get 5 root 3. All right, so in this triangle, this now bigger triangle, I would have a length of 5 root 3. Is that equal to the same thing as what it was on the unit circle? And the answer is no. We can talk about similar circles, right? They have the same scale factor. The radius is all everything is kind of scaled up the same, but they're not equal. There's a difference between, something being congruent and something being equal. So what the unit circle does is, again, it's a specific number of values that are on only when the radius is 1. We can still find cosine and tangent and, all those kind of fun things of angles that are not on the unit circle. They just won't have the exact same values. So cosine of theta equals x only on the unit circle. So in order for you to be able to justify this, right, the only way you could justify this if it's not on the unit circle is you would have to think of it as, and the reason why it equals x on the unit circle is because my radius is 1. On a non-unit circle, it would still be your x value, so whatever this distance is, but instead of dividing it by 1, which is your radius, you'd be dividing it by 10. So it's kind of like thinking it as x divided by r, and r stands for your radius. So on the unit circle, since your radius is 1, we just call it, cosine is x. But when it's not on the unit circle, we would say, if this radius was 42, you would have to, whatever your x value is divided by 42 would equal the cosine of your angle. So let me show you what that kind of means over here. If I have an angle over here, right, this is my x distance, this is my y distance, and this is my radius. So sine of my angle is going to equal y over r. So my y value over my radius. You can think of it as like SOHCAHTOA, right? So if here's my angle, opposite over hypotenuse. Cosine would be x over r. So x over your radius, adjacent over hypotenuse. Tangent would still be y over x. And then, of course, all of your reciprocal functions. which is just taking the reciprocal of the original one. So again, what I want you to understand is that only on the unit circle is sine equal to y and cosine equal to x. And that's just because this r value is 1. If it's not on the unit circle, you would have to take that y value and divide it by whatever that radius is. So again, if it's 42, divided by 42. If it's 1, or if it's 1.5, divided by 1.5. So let's look at a specific example where it's not on the unit circle. So if the terminal side of a central angle passes to the point 12, 4, then find the sine of theta. All right, 12, 4. So 12 on the x-axis, 4 on the y. Here's the point 12, 4. So we're going to make this a triangle, okay? So my x distance is 12, my y distance is 4. So there's an angle. Is this on the unit circle? Will this radius be 1? You might be able to tell right now, and if not, check it. How do you check it? Well, this is supposed to be a right triangle, right? So if this is a right triangle, then we can use Pythagorean theorem to figure out our radius. So 12 squared plus 4 squared equals r squared. So I would get 160 equals r squared. I'm going to reduce this to 16 and 10. So that's 4 root 10 is r. So is this on the unit circle? And the answer is no. So this is a non-unit circle because my radius isn't 1. All right, so let's answer the question. I want to find sine of theta. Well, sine of theta is your opposite, or y value over r value. So sine of theta is equal to y over r. So r is 4 root 10. So we're going to reduce 4 and 4. So I get 1 over root 10. And let's go ahead and rationalize that by multiplying by root 10 over root 10. So I get root 10 over 10. So in this one, I am just asking for the sine. So this is the relationship when so this is not on the unit circle. So my sine value is the ratio of your y value over your radius. Let's do one more and then we'll be done. So it's a little bit different. It says tangent of theta is equal to negative 4/3. Sine of theta is greater than 0. Then cosecant of theta is equal to something, and so is cotangent. All right. So if I know that tangent of theta is negative 4/3, so first of all, what quadrant is tangent negative in? So if you remember, we talked about tangent being positive in quadrants 1 and 3. Therefore, it's negative in quadrants 2 and 4. I also need sine to be greater than 0. In other words, I need y to be positive. So I can eliminate quadrant 4, because in quadrant 4, sine is definitely negative. So I'm telling you that this is negative 4/3, which means my y value over my x value has to be negative 4/3. Now, a lot of people think that negative sign has to go with the numerator. It really doesn't. So in this case, is our y positive or negative? Well, it's positive, right? Because it's in the quadrant 2. And that means our x value would be negative. So if I'm talking about this angle, so tangent of theta is opposite over adjacent, or in other words, y over x. This has to be 4 and this has to be negative 3. So let's answer the rest of the questions. Okay, we've got two sides of a right triangle. I want to figure out cosecant. Well, in order to do so, I need to figure out r. So let's do the Pythagorean theorem and figure out what my r value is. Looks like r is 5. Okay, fantastic. So cosecant's the reciprocal of sine. So if sine is y, this would be 1 over y. So, oh, I'm sorry, not 1 over y. It's r over y. So if sine is y over r, cosecant is r over y. So in this case, it would be 5 over 4. Cotangent, on the other hand, would be so cotangent would be the reciprocal of tangent. So instead of y over x, we'd have x over y. So my x value over my y value. So I'd have negative 3 divided by 4. So all we're really asking you to do here is just find different ratios. All right, that was a big one. Hopefully that made sense. I would practice some of this stuff and then just kind of look over it again and come to class with any questions. All right, bye for now.